Hello everyone, in this video I am going to teach you about improper integral. What is improper integral? If the interval of an integration is infinite, then we call it as a improper integral. The second condition is the interval is finite, but the integrand is discontinuous within that interval, then we call it as an improper integral. Let's see an example. For the first condition is very easy to identify. It's very obvious. First example, the limit a to infinity, some function, I take that x square plus 1 as a function, into dx. Here see, this is a finite limit, right? But this is infinity. So the interval is a to infinity. This is called an improper integral, or minus infinity to b, some function to dx. This is also an improper integral, or limit minus infinity to infinity, some function into dx. This is also called an improper integral. You can find it easily. Within C, you can say it is an improper integral. The second condition is somewhat different from this. Since the limit is finite, but the integrand is discontinuous in the interval. Let's see an example. Integral 1 to 5 x square plus 1 dx. Here see, you cannot say it within C, this is an improper integral, right? Because this is a finite number and this is also finite. So it's in real numbers. For the second conditions, the limit is finite, real numbers. But this integrand, this is called integrand. Integrand. This integrand is discontinuous within this interval. Then we say it as an improper integral. For a proper integral, the function is continuous within the interval. If a function is discontinuous maybe inside the interval, or at this point is discontinuous, or this point is discontinuous. Let's see an example. You will I understand it clearly what I'm saying. For example, I'm taking f of x is equal to 1 by x minus 3. Here, if x is equal to 3, this function is discontinuous. See, 1 by, if x is equal to 3, then 3 minus 3, that is 1 by 0, that is infinity. So, at x is equal to 3, this function is discontinuous. So, at this point, at x is equal to 3, this is the asymptote of x is equal to this function, that is discontinuous at this point, right? Okay, now let's see whether these integrals are improper or proper within these limits. For first example, the limit is minus 3 to 0. That minus 3 to 0 is the integral value must be between here, right? So there is no discontinuous within this interval. So clearly it is a proper integral. Proper integral. The second example, 0 to 3. The limit is 0 to 3. 0 to 3 means at the right end, this is the interval. This integral is discontinuous. At this point, this integral is discontinuous. So, this is a improper integral. Improper integral. The third example, limit 3 to 6. 3 to 6 means here, 3 to 6. For this interval, at the left end, the limit is discontinuous. So, this is also an improper integral. Improper integral. For fourth example, the limit is minus 3 to 6. Here is minus 3 and left end is continuous, the right end is continuous, but inside of the interval is discontinuous. So it's also an improper integral. I hope now you understand what is an improper integral. That is, an integral is improper if integral a to infinity f of x dx or minus infinity to b f of x dx or integral minus infinity to infinity f of x dx. The first condition is very obvious to identify. The second condition, the limit is real numbers, that is finite, a to b f of x dx, but the integrand is discontinuous within this interval. Then we will say it's an improper integral. Next, we will see how to solve an improper integral. Let's solve this problem. Integral x to infinity x power minus 2 dx. Clearly you can see it's an improper integral. So I'm taking one finite value instead of infinity. That is, I'm taking a limit b tends to infinity integral x to b x power minus 2 dx. Now this b is finite, you don't know the value, but this b is finite, so limit b tends to infinity. Now we can integrate this term. So limit b tends to infinity integral x power minus 2 dx. We know the formula, integral x power n dx means x power n plus 1 by n plus 1. That is x power minus 2 plus 1. That is x power minus 1 by minus 2 plus 1 minus 1. The limit is x to b is equal to limit b tends to infinity x power minus 1 means 1 by x. This is minus. So we have 1 by x minus 1 by x. The limit is x to b. Limit b tends to infinity. Apply the limits, that is upper limit minus lower limit. Here the upper limit is b. So minus 1 by b minus lower limit, that minus, apply x. So minus 1 by x. That is limit b tends to infinity. Minus 1 by b, minus into minus plus 1 by x. Next, apply the limit. This b diverges to infinity. So minus 1 by infinity plus 1 by x, right? Infinity is a very greatest value. Any greatest 1 by any greatest value, it's tends to 0. Some 0.000 something, right? So we can approximately write it as 0 plus 1 by x is equal to 1 by x.